Graphene and other carbon nanomaterials can replace scarce metals. That is the title of an article from physorg released on September the 19th, and it relates to a study by Richard Arvidsson and Bjorn Sanden from Chalmers University of Technology in Sweden. They've investigated the claim that carbon nanomaterials can act as replacements for scarce metals in electronic applications. Now, this is relevant to me because in my video series Techno-Decentralism, Practical Libertarianism in the Future, I discussed the idea of what I called monomaterialization, which is the convergence on one element to fulfill all productive roles. Now that might be an unreachable point, but the general concept is that fewer and fewer elements over time are needed to fulfill roles that previously required a diverse array of possibly rare elements. I pointed to carbon as the most interesting element due to its diverse allotropes and nanomaterials which can fulfill many different roles as they all have different properties. With relevance to the political aspect, the idea that large-scale monopolistic control and conflict can be lessened due to shorter supply chains and more localized production, it's interesting to see carbon nanomaterials evaluated on exactly that basis by scientists. The researchers at Chalmers studied the main applications of 14 different metals and by reviewing patents and scientific literature have investigated the potential for replacing them by carbon nanomaterials. The results were that 13 out of the 14 elements are candidates for carbon substitution, leaving only gold out of the list. Particularly promising is the substitution of indium and gallium by carbon nanomaterials. The researchers are aware of the political aspects of this concept too. To quote the article, "This offers hope," says Sanden. "In the debate on resource constraints, circular economy and society's handling of materials, the focus has been on recycling and reuse. Substitution is a potential alternative that has not been explored to the same extent, and as the resource issues become more pressing, we now have more tools to work with." Imagine being able to replace scarce materials with carbon, Sanden says. Extracting the carbon from biomass would create a natural cycle. Since carbon is such a common and readily available material, it would also be possible to reduce the conflicts and geopolitical problems associated with these metals, Arvidsson says. At the same time, they point out that more research is needed in the field in order to deal with any new problems that may arise if scarce metals are replaced. Carbon nanomaterials are only a relatively recent discovery, and so far knowledge is limited about their environmental impact from a life cycle perspective. But generally, there seems to be a potential for a low environmental impact, Arvidsson says. So the potential for what I've discussed in terms of techno-decentralism is now being underlaid by research.